Hello everyone, I'll be going over a short tutorial on how to use the Google Maps Geocoding API. This is the main documentation page. We can get here just doing a quick Google search on Google Maps API. Um, then this will take us to the main Google Maps API page. If we click on getting started and then scroll down to web service APIs, we will see the Google Maps geocoding APIs along other services that the Google API provides. So now we're back into the main documentation page. We have different information guides available, including a developer's guide, a get started guide. If you guys are not familiar with geocoding, it is basically the process of converting physical addresses, like a street address, into geographic coordinates, namely latitude and longitude. This is done so we can mark a place into a map and actually do calculations between many different places using their actual coordinates. Reverse geocoding is the complete inverse of the geocoding process. It is basically converting geographic coordinates into street addresses. Geocoding is often referred to as latitude longitude lookup, and reverse geocoding is referred to as address lookup. The Google Maps API provides this service for us freely within certain usage limits, which we can see here. We can do as many, with a free account, we can do as many as 2,500 free requests per day or 50 requests per second. That is either that is the addition of client side or server side requests. It doesn't matter what type of request we're doing. Those are the limits that we must comply with. Going back to the getting started page, we can now go to we can scroll down and see the basic request format and response format. We can do a request to the following, this address here, and we would basically add the type of object that we would want the response to be encoded in, and following that, we would add the address that we want to geocode and some other fields that I will later explain. And the response in encoded in JSON would look like this. Basically, the address components are every single field in the address, and they're labeled by Google automatically as either a street number, a route, a building, locality, all sorts of things, in their own classification level. And that encoding allows Google to find the specific address that we're looking for. And following that encoding, we can find the actual coordinates of the place that we're looking for. As you can see, the coordinates are not exactly the same, but they're very similar. This is because we are basically drawing the limits of the location that we're finding, like the actual limits on each different direction, basically, of the building or structure that we're finding. So the coordinates are going to be similar, but they're not going to be exactly the same, since the limits of a building, the different walls limiting the actual location, are not in the same place. And that's basically the simplest way we can do a request, to simply going to this web page and providing all of the fields or arguments that we need. This is an example of reverse geocoding. Now, if we go to the developer's guide, here we can play with an interactive query map, which we can use to visualize the way that the requests and responses, the way that they work with the geocoding API. So if we enter, let's say, FIU, it will find the address and provide the location. Here we can see the response consisting of either a JSON or XML object depending on how we specify the request. So this is for the JSON object, and now XML will be encoded like this. So that's a good way of visualizing how the whole process works of geocoding a specific address. If we scroll down, we'll find a basic format for an HTTP request, which we have already seen before. This is the basic address that we need to provide, and the output format is basically either JSON or XML. Based on what we put for the output format, we will get a different type of object response. So it's something to keep in mind, because depending on the object that is provided as a response to us, processing of that object will be different. In fact, there are two required parameters: an address or components separated by pipes, and an API key that we must provide. The reason why an API key is needed is because Google needs to keep track of basically how many requests your account is making to make sure that we are within usage limits. There are other optional parameters like bounds, language, or region, but those are not really necessary. What we truly care about is basically the address and the API key, as more often than not, those are the only two parameters that we're going to be using. The next step in the process will be getting an API key from Google, and we can simply do that by, the only requirement for that will be having a Google account. We can just go here, get API key, and that API key it can be used not only for the geocoding API, but also other APIs provided outside of even the Google Maps API. We just need to basically enable those services once we have the key. But that is not relevant to what we're doing right now. I just wanted to note that. We can just select to get a key, then accept. And the key will be automatically generated for us. I will not show you the key here because I don't want it to get stolen, as it is private to my account. But this is basically where you would see your Google API key automatically generated. Once we have our API key, we can start doing requests to the Google API Geocoding API. Now the next thing would be, how do we do those requests? Of course, we can always use our basic libraries in corresponding to each programming language to do either an HTTP request using built-in HTTP libraries or REST libraries for each programming language. But Google actually provides an easier way of doing this through their clients that they provide for each programming language. And these clients simplify the process of actually requesting data and parsing the data or selecting fields from the data later on. They also make sure that we don't go over usage limits, and we can actually specify a custom usage limit as long as it's obviously lower than the daily limits that Google provides, which actually simplifies the code quite a little bit, since we don't have to deal with time in our requests and all of that. So these clients are provided. If we go to the developer's guide, and here, as you can see, it says server-side clients, we can select it. And since the part of our project that deals with geocoding and accessing address information from other websites is written in Python, I'll just be showing how to download and install the Python client and some basic usage related to geocoding. So we can just click here. It will take us to the Python. If you wanted to read this page, it will give you some information why, some errors or some information about the clients or how they're used, why we should use a client. But I'll just cut straight to the chase and take us to the client GitHub page. As you can see, this client is so anyone can actually contribute to it. And all the code is basically open for anyone to see. Some information about the client is shown here. Some versions, how it has changed over time, some usage information. So you can see, you can just go here and like basically all the information is readily available to you. This Python client is easily provided as a Python package that we can download and install in our development machine. So if we go here to our virtual machine provided for development of our project, we can just input the following command: pip3 install update Google Maps, and it will take care of downloading and installing the Python package for Google Maps. It didn't download it in my case because I already have the latest version, but here's where it would basically download everything if you didn't have it installed. I have some sample code, some Python code set up to display some of the functions of the API. So if we go here, we would start by importing the Google Maps package. Then we would use Google Maps.client to basically authenticate into the API system. Here's where our key would go. So I would enter my personal key here. If you want to find your key, the easiest way of doing it is by googling Google API console. This would basically, the first result would take you to your basically personal console. If you go to credentials, it will basically show the API key. You can actually edit the rights of the API key by clicking here. You can do many things with the API key. But we'll just go ahead and copy the key, and we would input it here. This would help us again authenticate into the system. Once that's done, we can do a simple geocoding request by using gmaps that geocode. Gmaps is basically the argument that we get, the response that we get after authenticating. Here we will basically input the address that we want to geocode. The basic format is street address followed by city, by state, and even country if you need it. Although Google sometimes, actually most of the time, is smart enough to figure out basically what address you're looking for without having to specify every single field. So if we type FIU, it should be able to know that there's basically only one FIU, or the most common, if there's something else called FIU, some other building or location, it would find the one that is most likely to be the one that we're looking for. So basically this function or method that we're calling here, gmaps.geocode FIU, will return a geocode result, and I'll show you in a second how that result looks. But it is important to emphasize that this gmaps geocode function or method, what it actually does is it creates a request, HTTP request. It sends the HTTP request, it receives a response, and then it encodes or basically formats the response into an object. Basically, this object, this geocode result object, consists of a list of multi-level dictionaries. And that sounds complicated and everything, but it's actually quite simple, as we'll see in a second. Also, it is important to note that the geocoding method takes care of the usage limits. It will make sure that we don't go over the limit of requests for a given day, or even the maximum number of requests per second. So that is that's a very useful feature of it, and it's the main reason why we're using the Python client provided by Google instead of actually creating our own code. Now we can just go ahead and run this code so you can see how a geocoded response object looks like. So you can go to the working directory and then run the Python code. This is basically the output of this code. Here we're printing the longitude and then the latitude. And below that is the geocoded result object. This actually obtained first, and from this we derived the longitude and latitude. So here, as you can see in the geocoded object, which looks like this, is basically a list of dictionaries. It only has one big multi-level dictionary since we only queried a single address. If we do multiple address queries, then the dictionary will be longer. You will have more multi-level dictionaries. But as you can see, we can obtain the longitude by going to the first level geometry, then location, then LNG, and then the latitude, the same thing, but instead of LNG, LAT. You can actually see it here. If we go to location, then longitude and latitude, basically, well, actually geometry, which is found here. And then we go to location, which is one of the keys in the dictionary, and longitude, latitude. We can basically obtain the longitude and latitude. Everything else, as you can see, there are other fields named longitude and latitude, but those are basically the limits or the boundaries of the basic location, which is not the same as the center of the location or the actual reported point that the address that we looked up is located. So that's basically the simplest way we can actually geocode and search for an address and find its coordinates. Now you might be wondering how geocoding actually fits into our project, into the BreazeHome project. And basically we want to provide users with a way of knowing how long it would take them to travel and arrive to a certain property. This is useful since users can actually filter addresses, locations, and properties based on how far they are from each property and how long it would take them to get there. So basically our algorithm and our project takes advantage of that. And it is necessary that for every property that we pull from external sites like the MLS and listings, that we actually obtain the coordinates of that property and then store into a database for further algorithm analysis of, traffic and how long it would take to get there. And on a final note, there are other APIs like the Directions API or Geolocation APIs that can be used in conjunction with this to accomplish certain functions. Basically, the way this client API, this client Python client that I just showed you how to install and download, contains all of those basically access to all of those APIs. You would need to maybe enable it if it doesn't come enabled by default. Enable your API key to be able to use those services, but that should be pretty easy using the console, the Google Console API of your account. So in case that in the future the project evolves and other functionalities might need to be implemented, now you know how to do so, where to go to learn the documentation of other APIs provided by Google and take advantage of that. I certainly hope that you have learned something new from this tutorial and that it can serve future students as a guide on how to basically get started with the Google Maps API.